Now we're back. Good to see so many still here. It's been a very nice day. I hope you are enjoying it. We're ready for a final session with abstracts. So, and we're happy now first to introduce Kristine Stoe from Oslo University Hospital. We'll talk about short-chain fatty acids and atherosclerosis.
Yes,
Please.
thank you for having me. Back to real patients, and we're lucky enough to explore the microbiota gut-brain axis, although we think the gut's quite far from the brain, so there might be some links. It's part of my PhD work, so work in progress, and the whole project is called MIST, Microbiota in Stroke. And the title of this talk is Can Increased Fecal Levels of the short-chain fatty acid butyrate indicate poor absorption due to a disrupted gut barrier in patients with carotid stenosis? So, strokes, as we know, it's a common disease. In Norway, 11,000 hospital admissions yearly. And it's a major cause of death and disability, taking enormous amounts of resources. And 85% are ischemic strokes, the rest are hemorrhages. And about 1/4 or 1/5 of these are due to atherosclerotic lesions, usually stenosis in the carotid arteries. And so previously, like earlier years, not the last decades, atherosclerosis is looked upon as a chronic inflammatory disease and not a lipid storage disease, treated with antiplatelet therapy and cholesterol-lowering drugs. And for some patients, usually the symptomatic ones, meaning experienced a TIA or a stroke, with a moderate or severe stenosis based on velocities in the vessel and diameter reductions, can be offered surgery. However, we know that lots of patients have a really narrow stenosis, never experiencing a stroke, and some patients with just like a small plaque can experience a stroke. And we're chasing biomarkers or indicators of the unstable plaques in our research group, looking at the radiologies and also other biomarkers. And as we know, diet is a key preventer of cardiovascular disease. It was natural for us also to look at the gut microbiota. So we're looking at the short-chain fatty acids, which are key metabolites of microbiota-dependent fermentation products of starch and fibers, and energy source for colonocytes. And they're being looked at as the good guys, having anti-inflammatory properties, and we're wondering if that's only for colonic health or for cardiovascular disease and stroke as well. So in stroke population, there have been found lots of short-chain fatty acid-producing bacteria, and the same has been found in risk factors for stroke, especially in hypertension. Although there have been like conflicting evidence, in some studies there have been found loss of butyrate-producing bacteria, but still increased amounts of butyrate, and the amounts in feces and in plasma do not seem to be correlating very well. So here are just a list of different studies showing increased amount of short-chain fatty acids producing bacteria, and then reduced, and then they're going in all sorts of directions really. So we wanted to look at gut leakage markers as well, as some studies suggest that it can be due to a poor absorption. And as we know, the NOD-like receptor protein is like a key sensor of pathogens, eliciting a downstream cascade of events leading to a release of cytokines, for example, interleukin 18. And it might be linking the gut microbiota to the impaired gut barrier and also to systemic inflammation, which we think is a key driver of atherosclerosis. We also wanted to look at other markers of gut leakage, including the LBP that we have been talking about, discussed earlier today, and also the intestinal fatty acid binding protein, a marker of colonocyte damage, and also the CCL25, which is a marker of like a homing marker in the gut for T cells and lymphocytes. And so our research questions are obviously, can we find differences between patients with atherosclerosis, the symptomatic ones and the asymptomatic ones, meaning experiencing those who have experienced a TIA or a stroke within the last 3 months, so usually in the last 2 weeks, and healthy controls. So we wanted to look at levels of fecal short-chain fatty acids, markers of gut leakage, and also at the 16S sequencing and plasma levels. And so we've included 104 patients, and there were 81 available with fresh frozen fecal samples for the analysis, 43 patients and 38 control subjects. And for 78, we also have the plasma markers of gut leakage and inflammasome activation. And looking at the basic characteristics, they're quite different in the risk factors for stroke, obviously, and inflammation, but the body mass index is quite similar. The Bristol stool scale also did not differ between the groups, and we did a brief look at the diet and intake of bread, cereals, and vegetables, and we didn't find any large differences on that either. So we analyzed the fecal short-chain fatty acids. I think this is Gunn-Helen's love child. It's a distillation of fresh frozen feces, and then they further analyzing. And we did find differences in butyric acid between the patients and the controls. At first, we thought it must be the other way around, because we think that butyrate is a good guy, having anti-inflammatory properties. But in accordance to other studies, especially in the hypertension population, it's quite similar what they found there. And we also looked at the plasma markers of gut leakage, and we did not find any differences in the LBP, which I think that almost everybody finds in other studies. We didn't find that, but we did find significant differences in interleukin 18, obviously, since we think it's all inflammation, and also in the CCL25 and the intestinal fatty acid binding protein. So we thought maybe that the increased levels of butyrate in the patient group could be due to a poorer absorption due to a disturbed gut barrier. However, as we know in this field, the more we learn, the more confused we get, at least I. And so after sending this abstract, we started getting the results from the 16S sequencing, not finding huge differences in alpha or beta diversities or in many bacteria at all, but we did find an increased or an upregulated pathway in the butyrate, pyruvate to butyrate production pathway in the patient group. And we're also looking at the other pathways now. And we're also getting the metabolites in the plasma. looking at isobutyrate and butyrate together, but isobutyrate is just like a small proportion, so we think it might be representing butyrates. And I'm just looking at those data now and cannot find a correlation between the fecal and the plasma levels. However, it does seem like there's a difference in the levels between the symptomatic and the asymptomatic patients, which is very exciting in regards to picking the unstable plaques. So to be continued. What we've got so far is a finding that fecal levels of the butyrate were significantly higher in the patient groups compared to healthy controls. And the plasma levels of markers of gut leakage were also significantly higher in the patients compared with controls. So, and there's still a lot to find out in the plasma findings, and also there's a lot of more to investigate of the butyrate producing bacteria and pathways. And we think maybe there's a bit of increased production and a decrease of absorption in these patient groups. Yes, thank you.
So, thank you very much, Kristine. Questions? I think it's always extremely intriguing when the results are completely different from what you expect. So it's also a bit frustrating, of course. But how strong is the evidence that there should be reduced short-chain fatty acids in the stroke, you think, from before your study?
I think there are evidence pointing in all directions, really, and it depends also a lot on when you actually take the samples. So in the asymptomatic patients, some show that it's quite similar to the controls, and for the symptomatic patients, there can be differences because of the actual events before, after surgery, hospital diets, and everything. So I think it depends a little bit on how you do your sampling and when you take the test.
So you may think that the levels of the short-chain fatty acids may be influenced by more like some events surrounding the event, actually, or
maybe. As you say, it's complicated.
Right. But are the previous data not only investigating the butyrate producers, but also actually looking at the fecal short-chain fatty acids?
Yes.
Yes, there are.
So in strokes, not particularly in only in atherosclerosis, but all types of strokes. So maybe the stroke event itself might change the levels. But yeah, and lots of studies investigating the different risk factors.
Okay. I'm running out of questions. So unless you have any, I think we say thank you very much for a very nice presentation.